Hi, I'm Abhijit. This is part one of my video series on Docker and Kubernetes. Today, I'll talk about what was happening when Docker came along, what problems existed there, and what problems Docker solved. So, without wasting much time, let's get started. There were days in past when most software applications were deployed as one entity. That is, one set of instructions or code which used to run in a single process. So this kind of software architecture is something that we call monolithic software architecture, where the software is deployed as a single process. In most modern day applications which are developed today, we follow a different approach. Now, processes need runtime environments. What is a runtime environment? So a runtime environment, as the name suggests, is the environment in which the software is, and it at least needs the hardware requirements of the software that it is supposed to run. Like at least a set of instructions need memory and CPU to run, memory to hold the set of instructions, and CPU to execute those instructions. Uh, a software, depending upon what purpose it is supposed to solve, might have some other dependencies um, like a process might need some additional memory to dump some output, or my Python code might be dependent on some other packages. Also, my Python code would need a Python interpreter to run. So comprises uh, all of these things come together, and in a runtime environment, all of these things allows the software to function properly. Uh, so, monolithic. So a software deployed in a monolithic architecture has runs as a single process, and that single process needs one runtime environment. Like a Java program uh, runs on a Java virtual machine, which is created by Java runtime environment. This Java virtual machine has everything that is necessary to run that particular Java program, and thus the Java program runs and does what it is supposed to do, and all of this happens on the operating system. So this one can understand how this Java virtual machine provides the runtime environment for the Java program. Uh, Moving ahead, microservices architecture is a new, not a new in fact, but it's quite old. But it is a development approach which is more followed nowadays, and it is an approach that structures an application as a collection of small, loosely coupled services. Each of these services are responsible for a specific business function. All of these services working together enables the software to do all those things which it was supposed to do. Now, microservices architecture has its own list of advantages and disadvantages when compared to monolithic architecture, which is beyond the scope right now. During mid 2010s, microservices architecture started gaining momentum and started getting used more and more in the software industry, and we'll get to know why. So, microservices architecture also had a set of complexities back then. So, uh, before the advent of Docker, uh, these microservice architecture deployment had to use the technologies available at that time. So during those times, virtualization technologies had enabled creation of virtual machines. So microservices, most microservices applications were deployed in a set of virtual machines. Uh, it is not generally a good idea to share the runtime environment um, because a process might run into a conflict with another process with whom it is sharing the runtime environment. It might be a case that a process needs some hardware resource and the other process also needs the same hardware resource at that time. And this might cause either one or both the processes to not function properly. So services were run in different virtual machines, and these services were either deployed by using some configuration management tool, like the entire. We did not have to. just it's like the runtime environment is not just the code. So we need to push the code to virtual machines. Along with that, we need to push the static data that the software needs, and we also need to push different configuration, different other softwares on which it might be dependent. We need to push a lot many things when we talk about some practical softwares that gets deployed. So all of this used to be pushed to virtual machines using some configuration management tool like Puppet, Chef, or Ansible, and sometimes some package managers were used like RPM or APT. And using these package managers and configuration tools, the developers or the operators would uh, uh, create workflows to deploy the software in virtual machines. And sometimes even manual deployment used to happen where operators or developers would manually go to the virtual machine and manually set everything up. So that is something that used to happen before Docker. And uh, this used to bring its own set of complexities. This did not allow the microservices architecture to realize its full potential in terms of independence, scalability, resource utilization, and overall software architecture used to be missing. So that used to happen before Docker. There was another problem that used to happen before Docker, and that problem was but it was on my machine. Uh, so yeah, what does that mean? But it works on my machine. So but it works on my machine is something that a developer would say to another developer when the other developer would say that hey, your code is buggy. The first developer can say, but it works on my machine. So why does it work on one machine and not the other machine? So well, there can be environment differences like the operating systems. When we talk about environment differences, we talk about development environment, uh, difference in development environment. So the operating system can be different. Maybe the libraries or the packages that are being used by the code, those packages might not be present. There might be version mismatch in the packages, which might be causing uh, the application to not to function differently on different uh, environments. Then there can be dependency management issues, like the software might be dependent on some, the software might have some dependencies, and those dependencies are not consistent in both the environments. So that also might cause the software to behave differently on both machines. Then there can be system-specific dependencies. This would include platform-specific um, behavior, like uh, a software might work differently on Windows 7, it might work differently on Windows 11, it might work differently on a Linux machine or a Ubuntu machine. So a software might work differently on different operating systems. So that can be one reason why it works on one machine and not on other. Then there can be hard-coded paths or settings. Uh, Again, there can be some assumptions about the state. A developer might assume that this software is supposed to run on Windows machine and might would have coded the software in a way that it is supposed to run on Windows only and it does not run on Linux. So that can be that can create some problem, and then there can be other reasons as well. Most of these reasons of software not working on a machine uh, is solved by Docker. So yeah, what is Docker? So Docker is like a box inside which we can put the software and all the necessary parts into. So essentially, uh, what we do is we create a container. We use Docker to create a container which not only has the code but also the runtime environment. It also has all the dependencies that software needs, and it has everything basically. The interpreter, the entire runtime environment is present inside the container, and this container can be shipped across multiple platforms. Like we can deploy the same container on Windows, we can deploy the same container on Linux machine, we can deploy same container on Mac OS machine, we can deploy same container in a cloud server, we can deploy same container in a virtual machine. It can be deployed anywhere. And the code and the virtual environment, what or to be precise, whatever is inside the container remains the same. So this allows developers to easily build and ship and run software applications. And it also ensures that the software applications are consistent across different platforms and they solve that, but it works on my machine problem. So what problems Docker solved? Most of the problems. Uh, so the biggest problem that Docker solved is, but it works on my machine problem. So it allows consistent dependency management across environments. It allows consistent environment across um, different containers. It allows isolation since one container has one service. Most services, even though they are running on the same host, um, they are running in different containers, so they're isolated from each other. It allows portability. It allows you to uh, move containers from a Windows machine to a Linux machine or a Mac OS machine, and software behaves the same. And it allows scalability. When you see a load on a container is high, one can spin up a new container to share the load. So this allows you to uh, scale. This increases the scalability, and then there is efficient resource utilization. Unlike before Docker, one virtual machine would have one service, but now one virtual machine can have multiple containers, and each container can have its own service running within it. So this allows efficient resource utilization. It streamlined development workflow. It Now the developers have the power to not just send the code, but also the runtime environment with it, and it allows users to, it allows the developers to streamline the development workflow. They can create development images, they can create QA images, they can basically uh, it allows CI/CD, and it empowers so much. It gives so much power to developer and operators to streamline their workflows and do things in a much better way than they used to do before. And also microservices architecture. It has allowed microservices architecture to get rid of all the complexities and become more simplified. And software microservice architecture currently they use some kind of containerization technology, and they leverage this containerization technology to solve most of the complexities that uh, these microservice architecture have. Problems Docker solved. So yeah, there is the biggest problem that Docker solved is, but it works on my machine problem. It solved dependency management problem. Now the containers had consistent dependencies, since the dependencies are again the dependencies are present in the container itself. So the containers have same dependencies across different deployments, and that allows the dependencies to be consistent and the software to problems Docker solved. So dependency management problems Docker solved. Docker solved the problem. Most important problem that the Docker solved is, but it works on my machine problem. Uh, so the problems that Docker solves are dependency management problems. So since the dependencies are part of the container itself, these dependencies are consistent, and the same container, the like different containers of the same image, or you can say different containers of the same version behave same, and they have consistent dependency, consistent environment. So Docker containers allow uh, a runtime environment to different services, which remains consistent of the platform on which the container is deployed. So let's say a container or a Windows host will behave same uh, to the container of the same version on a Linux VM or a container of the same version on Mac OS. So it enables a consistent environment for the software, and this allows the software to behave same on different operating systems or different infrastructure platforms. And then there is isolation. So each of the containers they have their own, like each of the service have their own containers. So all of the services are isolated. All services have their own runtime environment. So all of these services are isolated from each other, and the services do not conflict with each other. Then there is portability. Uh, Containers are this like we can port the containers across different operating systems. A container which is working on Windows will behave same. We can port it to a Linux machine and it will behave the same. We can port it to a Mac OS and it will behave the same. And then we have the scalability fix, like when we have additional load on one container, we can spin up multiple containers of the same service, and those multiple containers can share the load. And then there is efficient resource utilization because uh, unlike running one service on one virtual machine, Docker empowers us to create different containers for different services, and these different containers run on same machine and also provide the isolation for the services. So it allows for efficient resource utilization. Docker containers are very lightweight, and we can run multiple containers on a single host. Then it streamlines development workflow. It Docker empowers developers and DevOps folks to streamline the development workflow and uh, push code across environments in a far better way and far less messy way compared to how it used to happen before. And Docker empowers microservices architecture. Docker was first released in March 2013, and the microservices architecture started gaining most momentum since around the same time. So Docker has actually empowered microservices architecture to become what it is, remove the complexities in microservices architecture, and it allowed microservices architecture to realize its full potential to become what it is now. So yeah, these are the problems that Docker has solved, and this is where we stop now. So I'll see you in the next video. Yeah, till then, bye.